Hi, welcome to this short tutorial on statics of solid mechanisms. This short tutorial is intended to continue the previous tutorial on finding the weight W of a body on a surface and then the weight WH at an elevation h above a surface. But in this case, our elevation wouldn't be given from the center of the surface. It will be given above the surface. My name is Adam Gatogo. Thanks for joining me. Well, in this slide, if you have followed me from the previous slide, it has been meticulously dealt with, where we said that the weight W equals to the mass times acceleration due to gravity, and then we've also expressed the force F equals to the gravitational constant G times the mass of the Earth times the mass of a body all over the radius of the Earth squared from universal gravitational law. And then in that case, we got our G, the gravity on Earth, to be G times the mass of the Earth over the radius of the Earth squared. And then we also said that at an elevation above Earth's surface, our force will be equal to the G times the mass of the Earth times the mass of a body all over the radius of the Earth plus the elevation of the body all squared. And then to find the weight of a body at a height, you multiply the mass of the body times the gravity at that height. And then when you do that, you equate WH equals to FH, that's MGH equals to GMME times M all over ER plus H squared. Then when you do your mathematics well, you will get an expression for GH to be G times the mass of the Earth over the radius of the Earth plus the elevation of an object all squared. And then when you divide this equation 2 by equation 1 here, and your mathematics is correct, you will get an expression for GH, that's the gravity at an elevation above Earth's surface, to be the gravity on Earth's surface times the radius of the Earth squared all over the radius of the Earth plus an elevation of a body all squared. Now let's take a look at this question and solve it. The question reads, the acceleration due to gravity on the surface of Moon is 1.62 meters per second squared. The Moon radius is 1,738 kilometers. Now, A, what is the weight of an object on the surface of the Moon that has a mass of 12 kilograms? And then B, determine the force exerted on the object by the gravity of the Moon if the object is located 1,738 kilometers above the Moon's surface. Now, in a question like this, what do we know? What have we been given? And what are we looking for? And in the question, we've been given acceleration due to gravity on the surface of Moon, GM, to be equal to 1.62 meters per second squared. And we have also been given the radius of the Moon, that's RM, equals to 1,738 kilometers. Then you convert that into meters because you are working in SI unit, and when you're able to do that, you get 1,738 times 10 exponent 3 meters to be the radius of the Moon. Now, what are we looking for? The question 8 says we should calculate the weight of the object of mass 12 kilogram on the surface of moon. Now, to calculate the weight of a body, you multiply its mass times gravity. But in this case, we are using the gravity on the moon because we have to calculate the gravity, the weight on the moon. So the weight of the object of mass 12 kilogram should be the mass of that object times the gravity of on moon surface, the gravity on moon's surface. We know the mass to be 12, gravity to be 1.62. So you carefully slot in the values into this expression, and then you get the weight of the object to be 12 times 1.62, and then when you press your calculator carefully, you get the weight of the object to be 19.44 Newton on moon surface. Now the second part of the question says we should calculate the force exerted on an object by gravity on moon's surface at a height h equals to 1,738 kilometers above the moon's surface. Now we know Fh, that's the force at that height, to be equals to the mass of the object times the gravity at that height. And then the gravity at that height above moon's surface is expressed as GH equals to the gravity on moon's surface times the radius on moon's the radius of the moon squared all over the radius of the moon plus the elevation of the object above the moon's surface all squared. Then we know the values of gm, r squared, and then h. So you carefully slot in the values into this expression. So you have gh equals to 1.62 times 1,738 times 10 exponent 3 all squared, and then our over 1,738 times 10 exponent 3 plus the h. Our h has been given us to be 1,738 times 10 exponent 3 meters. So you slot in it here, and then you square all of them. And when you press your calculator very well, you arrive at GH equals to 0.405 meters per second squared. And that gives you the gravity or above the moon's surface at a height of 1,738 kilometers. Now, what is the force at that height? The force at that height will give you the mass of the object times the gravity at that height. So we slot in the values. The mass is 12, and then the gravity is 0.405. And when you punch your calculator very well, you will get FH, that's the force at that height, to be 4.86 Newton.